The element gallium is an unexpected metal. It's a soft, silvery white metal that is solid at room temperature, similar to aluminum, but it can literally melt in the palm of your hand. It's bizarre and a little unsettling to see, but it makes sense. The melting point for gallium is relatively low, at 29.8 degrees Celsius. What could be easier? Simply place the piece of gallium in the palm of your hand and let the warmth of your body heat do the work. The melting point of gallium is 29.7 degrees Celsius. So it will readily melt in your hand or in a very warm room. Expect this to take around 3 to 5 minutes for a coin-sized piece of metal. You can buy a chunk of pure gallium for around $20 online. It's safe to use your bare hand for this experiment, but gallium has two properties that may make you wish to wear a pair of disposable gloves. First, gallium metal wets both glass and skin. What this means is the melted metal will leave finely divided gallium particles on your skin, giving it a grayish cast. It's not super easy to wash off, so you might want to avoid the issue. The other consideration is that gallium attacks other metals. So, if you usually wear a ring, you may want to wear gloves just to make certain no gallium or leftover metal is available to discolor your jewelry. In nature, gallium is never found as a free element and cannot be found in a substantial amount in any minerals. Rather, it exists in trace amounts in various compounds, including zinc ores and bauxite. It is easily obtained by smelting, however, and most commercial gallium is extracted as a byproduct of aluminum and zinc production. The largest producers of gallium are Australia, Russia, France, and Germany. Gallium has some very unique qualities. For example, although it is a solid at room temperature that is 22 degrees Celsius, it is still so soft that you could cut it with a knife. In addition, it has a low melting point of 29.7 degrees Celsius. So if you were to pick up a lump of gallium, it would literally melt from the warmth of your hand. Then if you set it back down, it would solidify again. Even with such a low melting point, gallium's boiling point is quite high at 2204 degrees Celsius, giving it one of the greatest ratios between melting point and boiling point of any element. At low temperatures, gallium is a brittle solid that breaks quite easily, and similar to glass, it shatters conchoidally. Gallium is used primarily in electronics. In fact, about 95% of all gallium produced is used to make gallium arsenide, gallium-3 arsenide, a compound used in microwave and infrared circuits, semiconductors and blue and violet LEDs. Gallium arsenide can produce laser light directly from electricity and is used in solar panels, including those on the Mars Exploration Rover. The compound gallium nitride (GaN) is used as a semiconductor in Blu-ray technology, mobile phones and pressure sensors for touch switches. Gallium bonds easily with most metals and is commonly used to make low-melting alloys. It is one of 4 metals, including mercury, rubidium and cesium, that are liquid at or near room temperature. Of these 4 metals, gallium is the least reactive and least toxic, making it the most safe and environmentally friendly choice for high-temperature thermometers, barometers, heat transfer systems and cooling and heating devices.
Liquid gallium cannot be kept in a glass or metal container because it expands 3.1% when it freezes. The Neutrino Observatory in Italy uses large amounts of gallium trichloride to study solar neutrinos produced in the Sun. Neutrinos are particles created in the first second of the universe, even before atoms, and are continually being made through nuclear reactions of the Sun and other stars. In its purest extracted form, gallium is a vibrant silver color. As a solid, it is blue-gray. Another unusual trait of gallium is that it can be supercooled quite easily. Supercooling is the cooling down of a substance below its freezing point without turning it into a solid. Approximately 95% of gallium consumption is in the electronics industry. Gallium has been used in nuclear bombs to stabilize the crystal structure. When painted on glass, gallium turns into a lustrous mirror. Gallium's boiling point is more than 8 times higher than its melting point on the absolute scale, the greatest ratio between melting point and boiling point of any element.